Hello. Okay. I will present today a few things on OTBTF, OTB remote modules used mostly for deep learning, but they also can be used for in other situations. So it's not only deep learning. So we are 3 people have contributed to this presentation. Vincent, which maintains the PyOTB, which is we can discuss that a bit later, and Mernouche, which is a head of archaeology lab at University of Chicago, and she used OTB to map some structures for archaeological purposes. So I will present you that just after, because cannot. Oh, okay, it's a bit slow. So this presentation is mostly in 2 parts. First, I will present you a few OTB things, very technical things, and after that, a long story of this archaeologist that used OTB at University of Chicago to find some ancient structure in the Middle East. So we'll start with OTBTF. After that, I will explain what's OTB prefetch and why it is used, and it can be used not only in deep learning. And finally, I will talk about OTB Onyx, I don't know, which is very useful when you want to use other deep learning frameworks than TensorFlow, because it can use a lot of deep learning frameworks. Okay, so I will be quick because there is plenty of documentation on the matter, but this is really cool. This is a new tutorial that we put online. It's basically a 3-day practical session, and you can copy paste command lines, Python code, and I think it's really easy. It's only in Python. So a good thing could be to port that into a notebook, but I didn't have time to do that. It's in the read the doc format, so you can easily copy snippets. And it used state-of-the-art technology like PyOTB, PyStack to access some spatiotemporal asset catalogs. So we use Planetary Computer, which is the Microsoft mega big data remote sensing data storage, and it's crazy if you never have used it. I encourage you to do so. You can Google QGIS plugin for spatiotemporal asset catalogs, and you have the Microsoft Planetary provider, which is already in there. So you can basically open in QGIS any image, which is free, like a Sentinel-2 or Landsat or MODIS. And so it's really incredible because it uses Stack, and all images are in the cloud-optimized GeoTIFF format. So you can read and process on the fly the data without downloading it. And Keras. So we build model and we apply them on images. There is new stuff in OTBTF. On the Python side, we add some layers and some operators. For instance, one-hot encoding and layers that can filter out the prediction of the networks. And finally, there is now no data support in. So when you have a whole black image, you don't want that your GPU computes apply the model on black areas. So it's now possible to specify one no data value so that the computation is only performed when there is actual data. And finally, we have a new split strategy in this application, which is used to select patches when you perform some patches sampling on the images. This is soon to be released open source software that performs the fusion of Sentinel-2 images with some available high resolution image, but that in this case you have one sentinel image every week and spot 7 image every year. So we perform the fusion of the two images, and we can have the full temporal time series, but in high resolution with the same spectral content than the spot 7 image. So we will release that soon, and it's already you can download. We have a few sites in France mainland when we have produced some test sites. If you want to use that, it's open data, so you can tell me if it's good data or if it's not good, because I don't know. And oh, sorry. Okay, so now what's next? We are currently working on the support Keras 3, which enable to use PyTorch both as model and as dataset. So it's very interesting. And we have also, we think we can reduce a lot the Docker image sizes. And finally, we are following closely what's in OTB regarding packaging, because we want that OTBTF can be shipped not in Docker, but like pip install or just pre-built binaries. So we are closely following what's been done in OTB to be aligned with that and ease the pain to the end user, because currently it's only the Docker images to use OTBTF, so it's not really friendly. Okay, well, I think I will invert the OTB prefetch. Oh, what is this thing? In short, it prefetches the data. We have some production processing chain in production, and we noticed that the GPU was not fully used because, in fact, there is some I/O bottleneck, and the GPU is waiting that the data is fetched from HTTP request. So the principle is to prefetch the data while the GPU is running the inferences. So this is the perfect world. It does not always work so fine, but we have noticed that it can be sometimes used not only for deep learning, but also for processing when you are reaching some remote files in HTTP. That's the case with Cloud Optimized GeoTIFF, for instance. It's really useful to do that because, you know, this guy is happy because the data is downloaded in the same time that it's processing another chunk of the image, you know. It tried to guess will be the next requested region, and in an asynchronous fashion. And yeah, sometimes it fails, but it's not a big deal because it will be read. The part that is not cached will be read as it's in this case. So it speed up a bit the process. I mean, in theory, because in practice, yesterday I tried to do some benchmark for you, and this was very long on some computer of mine because we had some issues with the DNS of this computer. So each time there is a prefetching, there is some latency because the misconfiguration slows the process of grabbing the data. So in sometimes it's better to open only once the data set and grab the data this way. Okay, so it's available here on GitHub. So how does it work in practice? So we use PyOTB here. This is a normal, so we consider a bandmat X application. So we put an image at input, and we use some dummy expression. We create one output file. And this is with prefetch. We just add upstream one application, prefetch, that will be used to grab the data before it reaches the bandmat. So it's really simple. It's like you can do that in deep learning. In deep learning, it's common to prefetch the data when you have a pipeline that generates some patches. It's the same philosophy here. We just prefetch the image before we feed the next application. So now I will change the subject and we talk about OTB ONIX. So ONIX stands for Open Neural Network Exchange. It's something heavily financed by Microsoft, Apple, Google, Facebook, and a lot of guys working on AI. And it's open source, and it basically consists in some kind of broker between a lot of deep learning frameworks. So this is really great because people that code some PyTorch model now in OTB. So you have just to compile from source this remote module, but it's really simple because Onyx is very well packaged. You can find the pre-built binaries for CUDA or for CPUs. It's well maintained, and it wants to be a standard for sharing deep learning networks. So I think it has some nice days ahead. And yes, it's reducing considerably also the Docker image size. So it's good for, I think, packaging. It's an ongoing work, always packaging. Yeah. So it's just one single application. And in fact, it's just a revamp of OTBTF inference application. We are using Onyx instead of TensorFlow engine. So the same bugs between these two applications, same bug in these two. Okay. And yes, we want to package it differently than with Docker. So here too, we are closely following what the OTB dev team is doing with the packaging, and one day maybe we will be able to install it very quickly, like with pip, for instance. I don't know. So I think I have now finished with the technical part, and I will now tell you a nice story about some guys trying to map these things in the Middle East. So these things are kanats. It's subterranean aquifers, antique subterranean aquifers. So basically, guys are digging holes, which are called shafts. And there is something here to bring the water down the hill and irrigates crops and houses and etc. And it's very ancient, like it's 3,000 years, I believe, something like that. And it has a crucial importance for the development of civilization. So for archaeologists, it's a thing to map these structures. It's really important. And there is cannot everywhere in a Western world. Yes, in the world, in fact. So you can see there is a lot of them in the Middle East. And in archaeology, you have many ways when you want to do that kind of research. You have archaeological remote sensing and a lot of other things based on fieldwork, archival research, ethnography. So it's completely different. We will talk about archaeological remote sensing. That's what we did. And we have worked on this region in Iraq. I will explain you why in Iraq, and specifically in this area here. So as you can see, we have some holes and we want to map them all. Remote sensing is not new in archaeology because the guys use some balloons, some pigeons to map things from above. So these guys use some balloons here in the desert. And US Air Force have declassified like 1 million images that were acquired by spy satellites during the 70s to spy over Russian atomic arsenal. So they want to know if it was big or not between during the Cold War. So all these images has been declassified 30 years ago. And yes, it was a Kodak imager that threw in the Earth some capsule that some planes were grabbing. It was crazy. And actually, it's not that bad. It's like 1 meter resolution. This is it. And which is interesting is if you look remote sensing image acquired today, you have nothing to see because everything has been destroyed. These cannot are completely destroyed, but in these times, they were still there. So archaeologists use these images to try to map these aquifers. So as you can see, it's okay, 1 meter resolution, but it's really faint sometimes. It's noisy and it's not auto-rectified. So there is a lot of work to exploit these images. And you see there is some shafts, but it's not to map automatically. So archaeologists did some work showing the exact center of the shaft, but it's quite challenging to use this data to train a deep neural network. So this is the data we used. We had 2 corona images, 8 bits, 1 meter spacing, and we had the red dots here. They are not really visible, but it's the center of the shaft that archaeologists put in QGIS. And the first challenge was how can we create some training patches from this data? So we used QGIS. And in the same time, some guys try to use the Facebook segment anything model. You know, it's a famous model that you can use giving him some context with a sentence like, okay, I want to map some structures which are aligned in a linear fashion, okay. And it's obviously, I think it's a future of AI for semantic segmentation, but right now it doesn't work really good on such images. So yes, it doesn't work. And we use a very basic approach. We took the shaft coordinates, we buffered them in with a circular object, and we rasterize it over the corona images, auto-rectified corona images. So this way we can generate some labels and images patches, and we can feed that to TensorFlow, to Keras, to train a very basic model. So we use UNet like you guys. So it's fast, it can be trained quickly. We minimize the softmax cross entropy, which is the spread between what we have and what we want the model to output. And we had 1 GPU. It took 1 hour over this GPU. And we have this matrix, which is really not good when you take a look. But the archaeologists were like crazy about the outcome of the inference process, because for them, it's better quality than the training data itself. So this is some, yes. This is some examples. So you can see that sometimes they missed the exact center, and I suspect that the auto-rectification of the images has been done in multiple times, so it can explain why it's not aligned. This is another example, you know. So the network is not so bad. Sometimes it misses some shafts, but it's at least a bit better, I think, than the human intervention on this line here. So they were truly happy with the results, and yes, it was a bit challenging. So this is an example. You can see here a small city. This is a corona image, and this is the exact same area. So yes, it is the same area. So we have nothing left nowadays, but on the corona image from the 70s, we have all the canats which are detected. And this is another area. So yes, a lot of things have contributed to the disparitions of these structures. I cannot really tell you, but it's man-made causes. Like there is no need to maintain this shaft. We want land to build some buildings, etc., etc. And also the piezometric water level has diminished, so there is no use. They are not useful anymore. Okay, so I have to acknowledge this work was being done at Chicago University, and they are active users of OTB right now. They want to build some kind of hub for archaeologists, so they can map their own Kanat in their region using some kind of model registry. Yes, so I will continue to work with them and OTB. So yes, I've finished.